Hey guys, welcome back. If you still think China's marine equipment relies on imported core tech, this 2026 SIA Shanghai Marine Expo will completely change your mind. Brand new domestic gas turbines, upgraded dual fuel generators, and zero-carbon ship systems are now fully mass-producible, ending decades of Western technological dominance in high-end marine power hardware. For generations, global high-value marine equipment was controlled exclusively by European and American industry giants, with Rolls-Royce, MAN Energy Solutions, and Ertsil locking up over 70% of the world's core marine power market before 2025. These foreign firms controlled every critical link, from high-temperature alloy material formulas and precision processing craftsmanship to intelligent control algorithm frameworks, forcing global shipyards to rely entirely on imported equipment and pay sky-high patent and after-sales fees. But 2026 marks a definitive turning point. Full-scale domestic technological breakthroughs have shattered long-standing Western monopolies, reshaping the entire competitive hierarchy of the global marine manufacturing industry. Today, we're doing a pure technical deep dive, breaking down every key parameter, performance upgrade, and global industry shift you missed at this exhibition. We'll integrate the latest 2026 authoritative market data, cross-brand global benchmarking, supply chain competition analysis, and long-term industrial forecasts to deliver a fully objective, data-backed industry review. No corporate PR spin, no exaggerated marketing hype. Only real mass production-ready technology and verified market trends. Let's get straight into the data. I actually flew into Shanghai specifically for this show earlier this week, and the vibe here is completely different from years past. Walking through the vast exhibition halls at Shanghai New International Expo Center, you can instantly feel the shift. Foreign booths are no longer the center of attention, and crowds are swarming the domestic equipment zones, checking out fully mature, mass-producible marine hardware. The 2026 SIA Shanghai International Ship and Offshore Engineering Equipment Exhibition officially ran from June 3rd to 5th at this venue. As the largest and most influential professional marine industry event in the entire Asia-Pacific region for 2026. This expo covered a total exhibition area of 45,000 square meters, gathering 680-plus top-tier marine equipment manufacturers from 32 countries and regions worldwide. It attracted over 42,000 professional visitors, including global shipyard procurement teams, offshore energy engineering contractors, maritime operation enterprises, and industry research institutions. Compared with the 2025 exhibition, overseas exhibitor attendance surged by 38%, and on-site intentional transaction volume exceeded $2.8 billion, hitting a 5-year historical high, and fully demonstrating its status as a core weather vane for global marine industrial development. The show focused on 6 core categories: marine gas turbine power systems, large marine generator sets, marine electric propulsion tech, offshore engineering hardware, intelligent shipping solutions, and zero-carbon green ship power systems. Unlike previous expos that prioritized conceptual prototypes and experimental technologies, the 2026 SIA exhibition centered entirely on commercialization, mass production, and practical industrial iteration. Every displayed piece of core equipment has obtained complete International Classification Society certifications, including DNV, ABS, and CCS, supporting large-scale batch installation and global shipping operation, representing the highest practical manufacturing level of the current global marine equipment industry. From an objective global industry perspective, this expo perfectly showcases how fast China's high-end marine power and offshore engineering equipment are evolving, and just how much domestic tech has improved in recent years. According to 2026 authoritative industry data from Clarkson's Research and Coherent Market Insights, the global maritime sector market size has reached $1.72 trillion in 2026, with a projected compound annual growth rate of 5.77% from 2026 to 2035, expected to surpass $3.01 trillion by 2035. In terms of market competition pattern, China has maintained its position as the world's top shipbuilding and offshore equipment manufacturing country for 16 consecutive years. By mid-2026, China's global new ship order volume and offshore equipment market share have broken 69%, far outpacing South Korea's 12% and Japan's 8% combined market share. Most importantly, the localization rate of China's high-end marine core equipment has skyrocketed from 48% in 2023 to over 70% in 2026, marking a historic end to the era of core technology dependence on foreign imports. 1. Marine gas turbine core technology and parameter breakthrough. Marine gas turbines are widely regarded as the most technically complex core hardware in the marine power space, serving as the ultimate benchmark to measure a country's high-end marine manufacturing comprehensive strength. Compared to traditional diesel engines, they offer way better power density, faster startup, far less vibration, and cleaner emissions. That's exactly why they're the top choice for ultra-large container ships, LNG vessels, high-speed passenger ships, and advanced offshore engineering vessels. For decades, the global high-power marine gas turbine market was strictly monopolized by GE's LM-2500 series and Rolls-Royce's Mount 30 series, with Western brands controlling over 90% of global market share and imposing strict technical blockades and patent barriers on emerging manufacturing countries. The 2026 SIA exhibition completely breaks this long-term monopoly with fully localized, mass production-ready domestic gas turbine models. At this SIA exhibition, the upgraded domestic heavy-duty gas turbine model GD25000 was fully displayed, representing the pinnacle of China's independent research and manufacturing capabilities for heavy-duty marine gas turbines. The improved GD25000 unit reaches a rated power of 25 megawatts, equivalent to 34,000 horsepower. Its standalone thermal efficiency reaches 38.5%. While the combined cycle comprehensive thermal efficiency breaks 52%. The unit's stable operating speed is 3,000 revolutions per minute, with a stable exhaust temperature controlled at 520 degrees Celsius. This core performance index is completely comparable to GE's mainstream LM-2500 gas turbine, reaching the world's advanced level, and even surpassing foreign products in comprehensive energy efficiency and operational stability. This gas turbine supports dual fuel switching between diesel and LNG. Its NOx emission index is controlled below 100 milligrams per cubic meter, fully meeting the latest IMO Tier 3 international marine emission standards. The total weight of the complete unit is controlled within 18 tons, achieving extremely high power density performance. This model is mainly applicable to 15,000 plus TEU super large container ships and large offshore engineering platform power systems, perfectly solving the long-standing high power supply bottleneck for China's ultra-large marine equipment. In addition to heavy-duty gas turbines, the exhibition also displayed the QD70 aviation-derived light-duty gas turbine, filling the long-term domestic gap in high-performance light marine gas turbine equipment. The QD70 light gas turbine achieves a rated power of 7 megawatts, with a comprehensive thermal efficiency of 35%. The overall dimension is 3.2 meters in length, 1.8 meters in width, and 2.1 meters in height, with a total weight controlled under 6.5 tons. Its ultra-compact structural design enables flexible installation in narrow cabin spaces that traditional heavy-duty power equipment cannot adapt to. Its core advantage lies in ultra-fast startup response, completing full startup and stable power output within 60 seconds. A 15% speed improvement over equivalent European light gas turbine products. This lightweight gas turbine is highly suitable for high-speed passenger vessels, luxury yachts, and emergency power supply systems for special operation ships, providing reliable instantaneous power guarantee for marine navigation safety and emergency response scenarios. When it comes to core manufacturing breakthroughs, these next-gen marine gas turbines no longer rely on imported high-temperature critical parts. They're equipped with brand-new domestic 1600 single-crystal high-temperature alloy blades paired with ceramic matrix composite CMC thermal barrier coatings. This ultra-thin 0.305 mm coating boosts high-temperature oxidation resistance by 40% and raises the blade's heat tolerance by 1:0, fixing one of the biggest pain points for long-term high-load ocean operation and extreme sea condition adaptation. These blades are built using precision lost wax casting and 5-axis linkage finishing processes, holding surface precision within 0.02 mm and pushing overall turbine efficiency 1.2% higher. This is a full break from Western material monopolies we've seen for decades. Previously, only the United States and the United Kingdom mastered 1600 plus marine single crystal blade manufacturing technology, with Western manufacturers imposing strict technical embargoes and high patent licensing fees. In 2026, China's fully independent blade batch production line has achieved stable delivery, cutting core component costs by 35% and shortening equipment delivery cycles from 18 months to 6 months, forming strong cost and efficiency advantages in global market competition. On top of new materials, these turbines use advanced dry low NOx adaptive combustion technology to maintain clean, stable combustion across all load levels, solving the unstable combustion and excessive emission problems of traditional gas turbines under low load and variable sea conditions. Paired with AI-powered fault diagnosis and remote operation systems, they extend mean time between failures to over 8,000 hours, drastically boosting reliability for long-distance ocean voyages. Honestly, seeing the GD25000 up close gave me chills. 10 years ago, this level of domestic heavy-duty marine gas turbine tech was nothing but a rough blueprint stuck in closed-door lab tests. Western analysts even claim China would need at least another decade to break the material and process barriers. Now, it's sitting right here on the exhibition floor, fully assembled, tested, and ready to power the world's biggest container ships and offshore platforms. That's a massive industrial flex no one can ignore. To put its competitiveness in perspective, let's do a head-to-head real-world benchmark with the global gold standard GE's LM2500. The American Classic hits 33.6% standalone thermal efficiency and maxes out at 51.2% combined cycle efficiency, while our GD25000 beats those numbers handily at 38.5% and 52% respectively. The LM2500 weighs nearly 20 tons, while the domestic unit cuts weight down to 18 tons for higher power density. Emission-wise, both meet IMO Tier 3, but the GT25000's adaptive combustion system delivers far more stable low-load performance in rough, variable ocean conditions. According to 2026 global marine power equipment bidding data, domestic gas turbines have officially entered the global open bidding market, capturing 12% of Southeast Asian and Middle Eastern marine engineering equipment orders in the first half of 2026, with overseas market penetration growing steadily month by month and gradually eroding the long-term dominant market share of Western brands. 2. Marine dual-fuel generator set technical parameters and performance upgrade. Marine generator sets are the backbone of every ship's electrical system, responsible for all onboard equipment operation, navigation support, and living power supply. In the maritime industry, there's no compromising on stability, low fuel consumption, low noise, clean emissions, and long service life. And these new gen units nail every single one of these metrics. Now, let's talk money. The numbers behind these engines are just as impressive as their technical specs. We're looking at a $14.82 billion global marine engine market in 2026 alone, and low-carbon dual-fuel power equipment is absolutely dominating growth here. It's hitting an 8.3% year-on-year increase, which blows traditional diesel engine growth rates out of the water. Every major shipping line is pivoting hard to dual-fuel hardware right now, and this Chinese tech is perfectly timed to capture that booming demand. The 8mil450DF medium-speed dual-fuel generator set displayed at the exhibition represents the highest level of independent research and development in China's large-bore marine power equipment, breaking the long-term monopoly of MAN and ERTSIL in the global large-bore dual-fuel engine field. This model adopts a 450mm ultra-large cylinder bore design. The rated comprehensive power reaches 9,200 kilowatts, equivalent to 12,500 horsepower, with a rated stable operating speed of 600 revolutions per minute. The average effective operating pressure reaches 2.4 megapascals, with stronger load impact resistance and operational stability than foreign similar products. It switches seamlessly between diesel and LNG dual-fuel modes. On pure diesel, fuel consumption sits at 185 G or kWh, but switch over to clean LNG, and it drops all the way to 145 G or kWh. That's massive cost savings for long-haul shipping runs. According to 2026 Shipping Enterprise Operational Cost Data, A 220,000-ton bulk carrier equipped with this unit can save approximately $220,000 in annual fuel costs, while reducing carbon emissions by 28%, achieving a perfect balance between economic benefits and green environmental protection. What really stands out is its brand new lean burn closed-loop combustion control process. It automatically tweaks the air-fuel ratio based on load, speed, and sea temperature, pushing combustion efficiency up to 98.8% and completely fixing the low-load carbon buildup issue that plagues older dual-fuel engines. Combined with a low-temperature SCR denitrification process, it keeps denitrification efficiency above 95% even in low-temperature conditions, fully meeting IMO Tier 3 global emission standards. This large-bore dual-fuel generator set is mainly used in large container ships, luxury cruise ships, and core power generation systems of offshore engineering platforms. Up to mid-2026, this equipment has obtained cumulative batch orders for 136 units from domestic and foreign shipyards, with overseas orders accounting for 42% of the total, covering Southeast Asia, the Middle East, and European regional shipbuilding markets. In the high-speed generator segment, the Ep.02 high-speed marine diesel generator set, exhibited by mainstream domestic manufacturers, has a rated power of 1,200 kilowatts and a rated operating speed of 1,500 revolutions per minute. Its optimized fuel consumption is controlled at 198 G or kWh, reaching the international advanced level of similar products. The complete unit has a compact layout size of 2.8 meters in length, 1.2 meters in width, and 1.5 meters in height, with a total weight within 3.8 tons. The 1-meter noise test data is stably controlled below 95 decibels, effectively reducing cabin noise pollution and improving crew navigation comfort. It is widely used in bulk carriers, oil tankers, fishing boats, and ship auxiliary power supply scenarios covering the mid to low-end civil ship market, and forming a full market coverage with high-power large bore units. In terms of marine intelligent power station system integration, the exhibited new generation marine power management system supports multi-level voltage platforms of 400 volts, 690 volts, and 11 kV, with a standard operating frequency of 50 Hz or 60 Hz. The system power coverage ranges from 500 kilowatts to 20 megawatts, covering almost all types of civil and engineering ships. Before 2025, high-end marine intelligent power management systems were fully monopolized by Ertsil and Siemens, with imported equipment procurement costs 40% higher than domestic products and extremely expensive after-sales maintenance fees. The 2026 upgraded domestic system realizes full independent research and development of core software and hardware, completely breaking foreign technical barriers. The whole system adopts PLC plus SCADA plus AI intelligent energy management architecture. The parallel operation accuracy strictly controls voltage deviation within 1, frequency deviation within 0.1 Hz, and phase difference within 5 degrees. The whole cabinet protection level reaches IP54 for cabin interior equipment and IP65 for outdoor equipment, adapting to harsh marine environments, such as high salt fog, high humidity, and strong corrosion. It realizes fully automatic parallel connection, intelligent load balancing, automatic fault recovery, remote real-time monitoring, and predictive maintenance functions, greatly reducing manual operation costs and navigation failure risks during ship operation. According to real ship test data in Q1 2026, this intelligent power station can reduce ship electrical system failure rates by 32% and cut annual operation and maintenance costs by 27%, with comprehensive performance exceeding imported mainstream products of the same grade. At present, this system has been batch applied to 86 newly built large ships and has obtained International Mainstream Classification Society certifications, qualifying for global large-scale promotion. 3. Marine medium voltage electric propulsion system technical advantages. Electric propulsion systems have officially become the new standard for modern green, smart ships. They outperform traditional mechanical propulsion in every key area. Wider speed range, way less vibration and noise, flexible layout options, and redundant safety design that makes ocean voyages far more reliable. According to 2026 global shipbuilding statistics, the penetration rate of electric propulsion systems in newly built large commercial ships has exceeded 65%, and it is expected to break 80% by 2028, completely replacing traditional mechanical propulsion systems in the high-end ship market. The 11 kV medium-voltage marine electric propulsion system displayed at the exhibition covers a power range of 5 megawatts to 30 megawatts. The variable frequency drive comprehensive efficiency is higher than 98.5%, and the matching permanent magnet propulsion motor efficiency reaches more than 97%. The whole system power factor is stably above 0.95, and the total harmonic distortion rate theta is controlled below 5%, far lower than international marine standard limits, effectively avoiding harmonic interference to precision ship electronic equipment. This high-standard medium-voltage propulsion system is widely applicable to ultra-large container ships, LNG ships, luxury cruise ships, and deep-sea offshore engineering platforms, providing high efficiency, low consumption, and high stability power. Support for high-end marine equipment. This year's upgraded permanent magnet synchronous propulsion motors range from 1 megawatt to 5 megawatts, running steadily between 100 revolutions per minute and 300 revolutions per minute, with a peak overall efficiency of 97.5%. That's 2% to 3% higher than traditional asynchronous motors. The biggest upgrade here is the nanocrystalline soft magnetic material stator, which cuts core iron loss by 25% and is the main reason for this huge efficiency jump. It also uses a brand new segmental laminated insulation packaging process, tripling partial discharge resistance and extending insulation lifespan past 150,000 hours. With 2.5 kilowatts per kilogram power density and IP56 waterproof and dustproof protection, it supports both water and air cooling for maximum flexibility. Global benchmarking data shows that European and South Korean equivalent propulsion motors have a maximum efficiency of only 95.2% with a service life of less than 120,000 hours. The 2026 domestic upgraded model achieves obvious leading advantages in energy efficiency and durability, with unit manufacturing costs 22% lower than imported products, possessing strong global cost-performance competitiveness. This series of permanent magnet propulsion motors effectively reduces ship body weight, saves ship cabin space, reduces overall ship energy consumption by 12% to 18%, and lowers daily operating costs, bringing significant economic and environmental benefits for ship operation and helping shipping enterprises further reduce carbon emission pressure. 4. Offshore engineering and deep-sea energy equipment display. In the offshore engineering equipment exhibition area, the 15 megawatts large offshore wind turbine independently developed in China was displayed on site, representing the world's top level of large-scale offshore wind power equipment manufacturing. Driven by global dual carbon goals, the offshore new energy industry has exploded in recent years, becoming the core growth track of the global marine engineering market. This turbine features a 242-meter rotor diameter and a 150-meter hub height, cranking out over 60 GWh of electricity every year. It starts generating power at just 2.5 meters per second wind speed and can survive extreme 70 meters per second winds, holding up even against super typhoons far offshore. Its massive blades are built with carbon fiber hybrid glass fiber composite materials, weighing 18% less while boosting bending strength by 32% compared to standard glass fiber blades. The surface is coated with a nano-hydrophobic anti-icing layer, which drastically improves anti-icing performance in humid, frigid marine environments and keeps it generating power for more hours every year, increasing annual power generation efficiency by more than 8%. The matching offshore wind installation vessel is 99 meters long and 34 meters wide, fitted with a 110-meter pile frame. It offers a 1,000-ton maximum lifting capacity, can drive piles up to 95 meters deep, and handles foundation piles up to 3 meters in diameter. Thanks to its dynamic positioning and pile frame synchronous calibration process, it keeps installation error within 5 mm even in rough, choppy seas, enabling fast, precise foundation and jacket installation in tough offshore conditions. According to 2026 global offshore wind construction data, China's offshore wind installation capacity accounts for 75% of the world's total. This new installation vessel can improve offshore wind farm construction efficiency by 40% and reduce single project construction costs by 18%. effectively solving the global industry pain points of high cost, low efficiency, and harsh construction conditions in deep-sea wind power projects. In the deep-sea oil and gas engineering sector, the sixth-generation semi-submersible drilling platform exhibited has a working water depth of 3,000 meters and a maximum drilling depth of 12,000 meters. The ship boasts a 4,000-ton variable load capacity and uses a mature DP3 dynamic positioning and anchor mooring dual positioning system. It can stably resist 17-level typhoons and 15-meter huge waves, suitable for deep-sea oil and gas exploration operations in the South China Sea, Brazil Sea area, and West African Sea area. I want to highlight a critical detail most industry reviewers miss: operational environment difficulty. A lot of people praise European offshore equipment for reliability, but most European North Sea operations face mild, predictable sea conditions with limited typhoon activity and relatively stable water temperatures. The South China Sea, by contrast, is one of the harshest marine environments on the planet. It's notorious for sudden super typhoons, violent seasonal swells, complex underwater current systems, and high salt corrosion year-round. If offshore hardware can survive and operate stably in the South China Sea, it can handle any offshore site across the globe. That's why this sixth-generation platform is such a game-changer. It's not just built for standard offshore operations, it's hardened for the worst possible ocean conditions. At present, only a handful of countries including China, the United States, and Norway have mastered sixth-generation deep-sea semi-submersible platform technology. In the 2026 global deep-sea engineering equipment bidding market, Chinese-made sixth-generation platforms have won 45% of global new orders, surpassing Norway's Aker Solutions to rank first in the world in delivery volume. In the emerging deep-sea mining equipment sector, the exhibited deep-sea intelligent mining system supports an operating depth of 2,000 to 6,000 meters, with hourly mining capacity of 300 to 500 tons and a collectible ore particle size of 2 millimeters to 50 millimeters. The total system operating power reaches 5 megawatts to 10 megawatts. It integrates crawler walking, hydraulic conveying, intelligent obstacle avoidance, and remote precise control technologies, representing the cutting-edge level of global deep-sea mineral resource development equipment. With the accelerated development of global deep-sea mineral resources, the international deep-sea mining equipment market size is expected to exceed $32 billion in 2026. China's self-developed intelligent mining system has broken the long-term technical monopoly of European and American enterprises, filled the domestic gap in high-precision deep-sea mining equipment, and obtained commercial trial orders from international ocean resource development organizations, laying a foundation for China's layout in global deep-sea resource development. 5. Intelligent shipping and zero-carbon green vessel technology. When it comes to smart shipping, the upgraded autonomous navigation system completely raises the bar for maritime intelligent travel. It fuses Baidu, differential GPS, and inertial navigation tech to achieve sub-meter positioning accuracy under 0.5 meters, with obstacle avoidance response locked in under 2 seconds. It supports both L3 conditional and L4 high-level autonomous navigation for all kinds of sea conditions. According to 2026 Global Intelligent Shipping Industry Statistics, the global penetration rate of L4 level full autonomous navigation in commercial ships is less than 8%, while China's upgraded system has achieved stable commercial application on coastal ferries and inland river cargo ships, with cumulative safe operation mileage exceeding 2 million nautical miles. And its safety accident rate is far lower than the global industry average. The system adopts 5 grams plus satellite plus shipshore private network triple communication guarantee, realizing automatic route planning, intelligent wave avoidance, real-time remote monitoring, and automatic fault recovery functions, greatly improving the intelligence level and navigation safety of modern ships. On the zero-carbon power front, the 6S50 MEC ammonia fuel marine engine hits 12,000 kilowatts rated power at 105 revolutions per minute. Running purely on liquid ammonia, it delivers nearly zero carbon emissions, with NOx emissions strictly capped at below 50 milligrams per cubic meter. And here's the clever part, they fixed the ammonia cracking process. Why does that matter? Because old ammonia-powered marine engines had 2 fatal flaws. First, they burned ammonia super inefficiently, wasting massive amounts of fuel and driving up operational costs. Second, they leaked excessive NO, a greenhouse gas way more potent than CO that defeats the whole purpose of green shipping. This new design, it kills both problems at once. It uses an innovative ammonia fuel high-temperature cracking suppression process to lock in efficient, clean combustion. It's fully built for 200,000-ton bulk carriers and large container ships. As global maritime emission regulations become increasingly stringent, zero-carbon ship power has become the core competitive track for major shipbuilding countries. Official 2026 IMO data shows that global shipping carbon emissions need to be reduced by 40% by 2030, driving the rapid iteration and popularization of ammonia, hydrogen, and methanol clean power equipment. At present, China's ammonia-fueled engine mass production technology is 12 months ahead of South Korean and European competitors, occupying a clear first-mover advantage in the global zero-carbon shipping market. The marine hydrogen fuel cell power system covers 500 kilowatts to 2,000 Q, with a hydrogen consumption rate of 0.8-1.0 GG or kWh and over 55% energy conversion efficiency. Its fully sealed micro-positive pressure packaging process keeps hydrogen leakage below 0.01%, meeting strict Class A marine explosion-proof standards. It delivers 200 to 500 kilometers of continuous sailing range, perfect for inland ferries, sightseeing boats, and port tugboats. With the continuous reduction of hydrogen energy costs and the improvement of industrial supporting facilities, marine hydrogen fuel cell systems will achieve large-scale popularization in short-distance shipping scenarios within the next 2 years. 6. Global Industry Trend Summary. Looking at this expo from an objective international standpoint, 3 clear industry trends stand out, all fully supported by 2026 authoritative global industry data and real market changes. First, China is rapidly boosting localization of core marine power equipment. Heavy-duty gas turbines, high-power dual-fuel engines, and medium-voltage electric propulsion systems are now fully independent and controllable, with overall domestic localization rates surpassing 70%. Breaking down the global competition pattern. The high-end Marine Corps equipment market, once completely monopolized by European, American, and South Korean giants, has undergone a fundamental reshuffle. In the first half of 2026, Chinese manufacturers have seized 35% of the global high-end marine power equipment market share. In the core offshore engineering equipment field, China's new order volume accounts for 69% of the global total, firmly ranking first in the world, while the market shares of South Korea and Japan continue to shrink, with their technical advantages gradually limited to individual high-end LNG ship segments. Second, low-carbon and zero-carbon shipping is no longer a future concept. It's an irreversible global trend. LNG, ammonia, hydrogen, and methanol clean power are quickly replacing traditional diesel engines. According to Clarkson's 2026 latest forecast, by 2030, over half of all newly built ships will run on low or zero-carbon power solutions, and the global zero-carbon marine equipment market size will soar to $74 billion. At present, China's zero-carbon ship power equipment has achieved batch mass production. The number of zero-carbon new ship orders received by Chinese shipyards in the first half of 2026 accounts for 52% of the global total, leading the global green shipping transformation process. Third, digital smart tech has fully penetrated the shipping industry. Digital twin ships, remote maintenance, AI fault diagnosis, and autonomous navigation systems are cutting overall ship operating costs by 20% to 30%. 2026 Global Maritime Industry Cost Analysis data shows that intelligent system transformation can reduce the annual comprehensive operating cost of a single large ship by $180,000 to $350,000, while significantly improving navigation safety and equipment stability. China's intelligent shipping solution market penetration rate has reached 41%, far exceeding the global average level of 22%. Becoming the core driving force for global maritime intelligent upgrading. At the same time, global deep-sea resource development and offshore new energy construction are speeding up, pushing marine engineering equipment to handle higher power, deeper water depths, and harsher extreme environments. The global offshore wind and deep-sea mining engineering market will maintain a 6.2% annual growth rate from 2026 to 2030, bringing huge incremental market space for high-end marine engineering equipment. Relying on a complete industrial chain layout, mature mass production capacity, and cost-effective technical solutions, Chinese marine equipment manufacturers are accelerating global market layout, continuously squeezing the market space of traditional Western brands. Beyond pure tech and market share, we also have to talk about the massive geopolitical and trade shift reshaping this industry right now. Western economies have rolled out strict carbon border adjustment mechanism CBAM starting in 2026, imposing heavy tariffs on marine vessels and offshore equipment with high carbon footprints. This policy was originally designed to suppress emerging manufacturing nations and protect Western legacy marine brands. But ironically, it's backfiring hard on Europe and the US. Thanks to China's early breakthroughs in zero-carbon power, high-efficiency dual-fuel systems, and low-emission gas turbines, domestic marine hardware already meets the world's strictest carbon standards out of the box. Meanwhile, many Western legacy engines and turbine models still rely on outdated high-emission designs that struggle to comply with new CBAM rules. This means Chinese marine equipment is not just cheaper or more powerful. It's now more trade-compliant and future-proof for the global low-carbon era. It's a huge structural advantage that's going to rewrite global supply chain rankings over the next 3 years. Overall, the 2026 SIA Shanghai Marine Expo perfectly showcases China's full strength in high-end marine equipment manufacturing. From game-changing heavy-duty gas turbine upgrades to large-scale offshore wind gear and zero-carbon ship power innovation, every tech and product on display is pushing the entire global marine and shipping industry chain forward. This expo is far more than a simple industry showcase. It is a clear signal that the global marine manufacturing competition pattern has been completely rewritten. China has bid farewell to the era of following foreign technologies and relying on imported core equipment, and has officially stepped into the global leading position in marine high-end equipment R&D, manufacturing, and commercial application. Overall, the 2026 SIA Shanghai Marine Expo perfectly showcases China's full strength in high-end marine equipment manufacturing. From game-changing heavy-duty gas turbine upgrades to large-scale offshore wind gear and zero-carbon ship power innovation, every tech and product on display is pushing the entire global marine and shipping industry chain forward. This expo is far more than a simple industry showcase. It is a clear signal that the global marine manufacturing competition pattern has been completely rewritten. China has bid farewell to the era of following foreign technologies and relying on imported core equipment, and has officially stepped into the global leading position in marine high-end equipment R&D, manufacturing, and commercial application. Honestly, after walking this entire exhibition floor and cross-checking every parameter, every new build, and every market trend today, I'm genuinely impressed. This isn't incremental improvement, it's full-spectrum industrial overtaking. A decade ago, we were importing every core marine power component. Today, we're building more efficient, more reliable, greener equipment that's ready to compete and win on the global stage. That's my full technical deep dive on this year's Marine Expo. If you love these no-fluff, parameter-driven industry breakdowns, make sure to subscribe and turn on post notifications. I cover all the latest global maritime, energy, and manufacturing breakthroughs before anyone else. Drop marine in the comments if you want more offshore tech content. And let's keep the conversation going. And stay tuned for my next video. I'm diving straight into China's top auto tech innovations to break down the latest domestic EV and smart driving breakthroughs, so you won't want to miss that in-depth technical deep dive either.